Bioavailability, the journey of a drug inside the human body. Have you ever swallowed a 500 milligrams tablet and assumed that all 500 milligrams entered your bloodstream? If your answer is yes, you're not alone. In fact, this is one of the biggest misconceptions in pharmaceutical science. Here's something that surprises many pharmacy students and even young pharmaceutical professionals. Just because a tablet contains 500 milligrams of medicine doesn't mean your body actually receives all 500 milligrams. Some of the medicine never reaches your bloodstream, but where does it go? Does it disappear? Does the stomach destroy it? Or is there another reason? The answer lies in one of the most important concepts in pharmaceutical science, bioavailability. And once you understand bioavailability, understanding bioequivalence becomes incredibly simple. Hello everyone, and welcome back to the Bioequivalence Masterclass series on PharmaHealth Insights. In episode 1, we understood what bioequivalence is, why bioequivalence studies are required, and why regulatory authorities insist on proving that a generic medicine performs like the reference product. Today, we're going one step further. Before comparing two medicines, we first need to understand how a single medicine behaves inside the human body. Let's answer one simple question. What exactly is bioavailability? In the simplest possible words, bioavailability tells us how much of the medicine you swallow actually reaches your bloodstream in a form that can produce its therapeutic effect. Notice something important. Bioavailability is not asking how much medicine is inside the tablet. That answer is already printed on the label. Instead, it asks a much more important question. How much medicine actually became available to your body? That is why it is called bioavailability, available to the body. Now, another question naturally comes to mind. If a tablet contains 500 milligrams of medicine, why doesn't the entire 500 milligrams reach the bloodstream? To answer that, let's follow the complete journey of one tablet. The journey begins the moment you swallow it. The tablet travels through the food pipe and reaches the stomach. Many people believe medicines start working as soon as they enter the stomach. Surprisingly, for most medicines, that's not true. The stomach is simply the place where the tablet begins preparing for its journey. Inside the stomach, the tablet comes in contact with stomach acid and digestive fluids. Gradually, it starts losing its original shape. It simply means that the liver breaks down part of the medicine before it reaches the rest of the body. Let's go back to a 500 milligram tablet. Suppose the tablet contains exactly 500 milligrams of drug. After disintegration, after dissolution, after absorption, the medicine reaches the liver. If the liver breaks down 100 milligrams, only 400 milligrams finally enter the bloodstream. Now, our original question has been answered. The entire 500 milligrams didn't disappear. Some of it never got absorbed. Some of it was broken down by the liver. Only the medicine that finally reaches the bloodstream is available to produce the desired therapeutic effect. And that is exactly what bioavailability tells us. Now, here's another interesting question. Suppose two pharmaceutical companies manufacture the same medicine. Both tablets contain 500 milligrams. Both look identical. Both pass quality control tests. Can we immediately conclude that both medicines will perform exactly the same inside the body? Not necessarily, because bioavailability is not only about how much medicine reaches the bloodstream, it is also about how quickly it gets there. Let's understand this with a simple example. Imagine two friends traveling from Bengaluru to Mysore. Both leave at the same time. Both eventually reach Mysore. So the destination is the same. But one reaches in 2 hours while the other reaches in 4 hours because of traffic. Both completed the journey, but one reached much earlier. Medicines can behave in exactly the same way. Two tablets may eventually deliver almost the same amount of drug into the bloodstream, but one may do it much faster than the other. This brings us to two simple concepts. The first is the extent of absorption. The second is the rate of absorption. The extent of absorption answers one question. How much medicine reached the bloodstream? The rate of absorption answers another question. How quickly did it reach the bloodstream? That's all there is to it. Now think about a painkiller. When you have a severe headache, you don't just want the medicine to work. You want it to work quickly. A medicine that reaches the bloodstream faster usually starts producing its effects sooner. At the same time, the medicine must also reach the bloodstream in the required amount. So both things are important, the right amount and the right speed. Now, let's connect everything we learned today. The tablet first breaks apart. That is disintegration. The drug then dissolves. That is dissolution. The dissolved drug crosses into the bloodstream. That is absorption. The liver processes part of the medicine, that is first-pass metabolism. The medicine that finally reaches the bloodstream represents its bioavailability. Simple, one complete journey. Now let's connect this to bioequivalence. In episode 1, we learned that bioequivalence studies compare two pharmaceutical products. But compare what exactly? Now you know the answer. Scientists compare the bioavailability of the two products. They want to know whether both medicines deliver approximately the same amount of drug into the bloodstream and whether they deliver it at approximately the same speed. If both products behave similarly inside the human body, patients can expect similar therapeutic effects, and that is why bioavailability is called the foundation of bioequivalence. Before we end today's episode, remember just one sentence. A tablet may contain the medicine, but only the medicine that reaches the bloodstream can produce the desired therapeutic effect. That single sentence summarizes the entire concept of bioavailability. In the next episode, we'll answer another very important question. Do all pharmaceutical products require bioequivalence studies? Do tablets, capsules, syrups, injections, creams, eye drops, and inhalers all follow the same rules? Or are some products exempt from bioequivalence studies? We'll answer all these questions in episode 3. If you found this episode useful, don't forget to like this video, subscribe to PharmaHealth Insights, and share this bioequivalence masterclass with your friends and colleagues. Thank you for watching. I'll see you in episode 3.